So I'll begin the Prac by acknowledging country. Again, I'm sitting on Gubbi Gubbi country, Sunshine Coast, Queensland. Beautiful day here. The birds are chirping, the chickens are squawking. And it makes me feel pretty good to be on this country. If you want to drop in the chat the names of the countries where each of you are, if you know them. And if not, check out on gambay.com.au to have a look for locations, names of the languages at the locations that you're at. And there's a place names section there that might even have names of places that are close to where you are. So today's Prac, we're looking at preparation of language data. Also in the Zoom chat, I'll drop a link to the page for today's session. And this one's pretty simple. It's just, there's two links there to collabs and a link to a knowledge base. So we'll begin by working through the collabs. We'll check in as we go through them. And we'll go through this process of some manipulation of language recording formats, and then some data manipulation of ELAN files, which are a common language documentation format. So I'll share the screen. I'll just get that set up. Okay, so here we have a collab. This will take us through a few different steps of getting files, working with files in collab, audio files, and looking at file parameters and manipulating files. So if you can open up this collab yourselves, and then first thing you'll need to do is to save a copy of it in your own Google Drive so that you can save the changes that you make. I'll also drop in the assessment sheet for this week's module into the Zoom chat. So as we go through this, have a look in part B, the Prac assessment. Because as we're going along it, some of the outputs that you'll make will be submissible for assessment. So you can use the links from that first Voyages #2 data page to open up the collab. And we'll see it's pretty similar to what we looked at with the collabs last week. There are a bunch of text cells and some code cells. You'll notice that when the text cells are formatted with headings, it gives us a collapse, a little triangle on the side of the text cell, which collapses code cells that follow it. So this is a handy device just to simplify the presentation of a collab. And particularly when we have lots of text, it gives us a way to kind of close up big blocks of information. So if you open it up, if those are closed, just click on the little triangle to open them. Now the first things we'll do is to install some software tools, some packages that we'll use in the collab. The two main programs here are FFmpeg and the Wave Python package. So FFmpeg is a media manipulation tool. It's an extremely powerful bit of software. It's handy for changing formats of media files, converting movie files from one format to another, manipulating audio by mixing stereo audio into mono and by changing sample rates and bit depth of audio. So I won't go too much into the detail of what of sample rates and bit depth of audio is. We'll cover that in a lot more detail in an upcoming module. For the purposes of today's activity, we'll compare the quality of some different bit depths soon, and you'll be able to hear that the bit depth and sample rate affect the quality of the audio file. So you might have come across this with MP3s, that a low quality MP3 might be at maybe an 8 kilohertz sample rate, or a high quality MP3 might be more of a 16 or 32 or 44 kilohertz sample rate. So the higher the number of samples in the audio file per second, then the more data there is in the audio file to kind of represent what's happening in the audio signal. So what we're going to do in the Prac here is to convert some files, and we're just picking up some values a bit at random. Doesn't really matter for the purposes of today's Prac. So let's get started by connecting the runtime up on the top right. And this one, we don't need a GPU or a TPU. It'll be satisfactory to use the CPU on the server. So we can connect to that. And then I'll click the play button next to the first code cell to begin the process of installing FFmpeg. And this has happened pretty nicely. FFmpeg is already installed. This is probably from me just running it before. You might take a little bit longer on your machines or for your collab to go through that process of installation. And we also import this WAV package. This is a Python package which allows us to work with WAV files easily. We don't get any feedback about the process of importing there. So at this point, we've got these two programs installed on the server or in the virtual machine. And now we need some audio to work with. So I have uploaded an audio file into this repository, the Voyages Prac repository. So here it is. This is a lossless format, FLAC file. We're going to download that into the Colab, and then we'll convert it into a WAV. So the process of downloading, I'll open up the file browser on the side here, and here we use this wget command to download the file from this URL. Now the file name, when I look at it in the repository, I can see it here, abiru1.flac. This is the location of the file, but if I was to try and download that directly using the wget command, it would download this HTML page, the web page, which is the kind of the publishing format of this in GitHub. So to access the file itself, I need to get the sorry, just a second. There's a message in Slack that I think Leo's gone to the wrong video, the wrong Zoom as well. Okay, so to get the raw audio file, I can right click on this view raw link and copy the link address. Essentially, it's the same as the page name, but with this question mark raw equals to, oh, sorry, raw equals true appended. So I can use that as the URL to access the audio data. So this is the URL of the file with $raw equals true appended. Now, if I was to do that by itself, with the simple wget command, let's try that. I'll run it. It appears to connect and it seems to save the file and it recognizes that it's an audio file. So when I look in the file system, I get the file, but you can see that it's downloaded it with the raw equals true suffix as part of the file name. So I can avoid that by specifying an output file name in the wget command. So let me delete the one that we just downloaded. And I'll run that command again. And now we downloaded it and you can see it's saving the file to this file name, very1 FLAC, and there it is there. So specifying the file name gives us a neater file to work with. Now that we've downloaded that file, we can use another program called ffprobe to have a look at the properties. So let me toggle the cell to see what the command is. And it's very simple, ffprobe and then the file name. I'll run that cell and it tells me about this file. The main information that we're interested in here is the last section, which is the data about the audio stream, the media stream. So we know that there's a single stream of audio in here and it's in FLAC file format. There's some information about the encoding technique and it tells us some duration, 3 minutes and 69 seconds and, no, sorry, 3 seconds and 69 milliseconds. And it has a bit rate of 160 kilobits per second. 16,000 hertz or 16 kilohertz. And it's a mono file. So there's a single channel. It's not stereo. And it's a 16-bit depth signal. Now we can use FFmpeg to convert the audio. Just one reminder, notice that these commands are prefixed with the exclamation mark. You can zoom into that. Hopefully you can see it a bit better. So exclamation mark prefixing the command. So this instructs Colab to run the command in an underlying shell rather than as a Python command or as a Python instruction. So for all of these commands that we want to run in underlying shells in the virtual machine, we prefix those with the exclamation mark. And likewise here with the apt install. So we want to, this installs FFmpeg into the virtual machine using the underlying shell rather than doing a Python-esque installation. Import wave doesn't have the exclamation mark because this is an instruction that we want to happen in the Python environment. Okay, so we've downloaded our audio and we've seen the properties of the audio file. Now we can use FFmpeg to convert that from FLAC file to WAV file. So the command is ffmpeg followed by a series of arguments or parameters, and these are described above the code cell. Hide banner turns off this sort of version information about the program. So ffmpeg can be quite verbose in telling us about its installation setup before it gives us the actual data. This is the input file name. The AR is a sample rate specification. So if the original was at a higher sample rate and we wanted to downsample, we could specify that here. We could give it we could say, make an 8 kilohertz file instead of a 16 kilohertz file. And this is our the bit depth. The sample format is 16 bits. AC1 is the number of channels. So if we wanted a stereo channel, we could stereo output, we could specify AC2 there, but we want a mono file, so we'll specify AC1. And then we give it a file name. Now, ffmpeg uses a bit of magic to work out what format, which codecs to use, codec format, the compression systems to use, based on the file names that we give it in the suffix. So if I press play here, it gives me some information about what it's doing. So the input stream is from the FLAC file. It tells me what the input format is, and then it tells me how it's going to map the streams from the input stream to the output stream. So the FLAC file to the WAV, so PCM S16LE is a designation of the WAV file, the WAV encoding format. This happens all very quickly because it's only a short file. But if it was say an hour-long file, that could take a while to process. And we also see that there's no video stream in this. Okay, so that's that will have happened, and there it is sitting in the file system. Now we can use the WAV program, or the WAV Python package that we imported earlier, to open that WAV file. And so here we use this command wave.open file name, and then RB tells us to read the binary stream of the file. We get some parameters of that file, and then we can output them and see what file information it can give us. So let's double check that. The n channels, the number of channels is 1. So it's a mono file. The frame rate or the sample rate is 16,000 hertz or 16 kilohertz. The number of frames is the length of the file, and we can convert that into a more human readable seconds, milliseconds value by dividing the number of frames, the length, the frame length, by the frame rate, by using these this simple sum here to give us a number of seconds. Okay, how'd everyone go with that?
No problems.
Good. Super. We seem to have lost Leo. Oh well. Hopefully he can catch the video later. So for the assessment, what we're interested in seeing is essentially this section here. So when you duplicate or when you save the copy of the collab and run through these, check that your output is in the same sort of style and is showing that it's 16 kilohertz and mono and the format. So these code cell outputs tell us that it's converted into the right format. So if you like to play around with changing some of these values and see what happens, you can even change that to an MP3. So now I would expect to have a very low resolution MP3 show up in my list. So if I press play, I might take this guy. So we can use FFmpeg with different configurations of the parameters. And if there happens to be an existing file, we might need to click into the code cell and tell it to overwrite. You can also add I think it's a -y flag into the command to forcibly overwrite anything that's existing. So there's MP3 here. Now we can't use the wave program to look at the properties of the MP3. So it's enough that we can see here that the bit rate's very slow, very small. If we wanted to, we could maybe add an audio player to listen to the MP3 and let's go to the bottom of the page. I can copy the code from here's one I prepared earlier. So let's put a code cell here from IPython display import audio, and then we use that audio command and change the file name. And if I run that, no, one MP3. If I run that, I should get that nice little audio player, and I can listen to it. Let's bring that a bit closer up, and we can do a comparison of the effect of dropping that sample rate down. So that's the 8 kilohertz sample rate, pretty low res. It's okay for human speech. Would make any audio recording of music sound really awful. Let's see if we can drop it down even lower and see what the sound is like. So I'll recompress that at too small. Maybe that's even too low for MP3. Nope. Okay. Maybe I had 8,000 might have been the minimum already. So we can hear that it is very low resolution. If I was to do it without changing the sample rate, so this is doing a straight conversion from an input to an output, it should use the sample rate of the original. And I need to replay this code cell to build that player again. So that sounds reasonably higher quality than the 8 kilohertz example. Okay, so that's some audio. Let's have a look at extracting audio from a video clip. Now, the process of getting the video clip that I wanted to work with is rather convoluted. So this might take you a moment to go through the steps. It's published at Paradisic, which is it's an online archive of language recordings. And to use Paradisic, first we need to make an account. So if you open up that link, go to Paradisic, and up in the top right-hand corner, sign up for the service by putting an email address in and a name, some passwords. And when you click the sign up button, it will send you an email. If you open up the email link, email and follow the confirmation link, you'll be taken back to Paradisic with the account activated. Maybe give me a thumbs up when you get to that point of signing into Paradisic with the account, and then we'll proceed with looking at where this file is. Okay, Lucinda, you got it? Hunter's in. Yeah, Suvita. Okay, Janet, are you playing along or are you observing? Probably observing. Okay, so we're into Paradisic. What happened to my window? Okay. Now I've got to sign in and find this corpus. So Paradisic has a phenomenal collection of recordings, many collections. You can click on the map and have a look around, or click on collections and then click on the map. So dashboard will be empty because it's sort of designed for the people who submit data into the archive. But you can see there's collections of material from around the world. Some from India. Oh, there's some people have been very busy. Loads of different languages. So we're looking for, I'll copy the link address, I'll put it in the chat as well if that helps. This is some material that Nick Teberger recorded some years ago from Vanuatu. And we can see on the map, on the, zoom out a little bit. So Vanuatu is the island chain out there. And this is a slice of Nick's deposits in this repository. So within this collection, there are 10 files. So this is one particular session recording of this story. And so we have these different formats. We're interested in working with this M4V file. So you can click on the view link, and we're presented first with the conditions of access. So essentially this is saying that we can use this, or we can work with this file if it's for education use or scholarly research, not for profit. Copyright is held by the owners of the files. There'll be sometimes the collections in Paradisic have more detailed copyright information as part of the collection. So we can read through that and click the checkbox at the bottom, click submit, and then we get access to the file. Now, for the files like the MP4s and the movie files, they might take a while to load, but we can preview them in the browser.
Pinatraso ni off. Alright.
And the link here at the bottom, we can download the file. So if you can download that, it might take a few minutes, depending on your network connection. Then we want to get that into Colab. So these are the steps that are at, whoops. These are the steps that are detailed here that we've just been through. Review the conditions of access, download the file, and then when it's downloaded, we'll upload it to Colab. So this one's just about done. Now I found that uploading to my Google Drive was quicker than uploading directly into the Colab, but it's up to you. Remember from last week's session, there are a few different ways to get files into Colab. You can just drag and drop them into the file directory or click the upload icon. So I could do that, find, there it is, the MP4. If I click open and upload it into this directory, this method of getting the files into Colab is transient. So when this runtime is turned off and then turned back on again, the files over here are likely to disappear, or they will disappear. So you'd have to re-upload that. And you can see that's probably going to take quite a while. So another approach is to open your Google Drive and upload the file to the Google Drive and then mount that in the same way that we did last week using the drive.mount technique. So I'm going to cancel my upload because I have mounted, or I uploaded mine into the Google Drive earlier. So I'm just going to clean up here a little bit. I'll leave these Abui files from before. And I'll use the drive mount method to load my Google Drive into the Colab. So remember that we'll have to authenticate first by clicking that link, choosing the account to sign into. Copy the authentication code, paste and enter. And once that has authenticated, the drive will be mounted Might need to refresh over here. So there it is. There's my drive. Whoop, that thing came back again. So there's my drive. And inside it, I have the Colab data folder. And inside that is the movie file, which I've uploaded earlier. So we'll just tread water here for a moment until you get the file, the movie file, into the Colab, and maybe let me know when you're ready to continue. So once the file's uploaded, we mount the drive, and this cell will change my working directory from being out here into the Colab data file. And this is just to make the commands a bit simpler to use. So you can run ffmpeg and pass the full path into the input and output parameters. But I like to do this just to see what I'm working with. So first I change directory, and note here, this is slightly different. We use this percentage sign as a prefix to the cd command. And then we do a list. So the difference between this, the percentage and the exclamation, is that the percentage tells the Colab to work in tells the underlying shell that we want to work in the current environment, whereas this exclamation mark will run an arbitrary shell, so it's not always consistent. So if you were to type exclamation mark cd and change directory and then run the ls command, you wouldn't necessarily get the same output. So it did in this case. Nice. Oh, okay, that's because I've changed into that location. If I cd somewhere else, so this is taking me back to the original starting place and do a list. Then I see these are the files that we're working with before. Now let me try changing to that Colab data file folder and do a ls. See, it has moved into that folder, but then it's brought us back to the original place. So it hasn't, the shell hasn't remained there. So we use the percentage sign to change, and then do the list. Then it gets me into the proper location. Now I can run the ffmpeg, and I specify the input file, and the VN is a shortcut for no video stream or no video codec. And then I give it an output file name. It'll work out that I want a WAV file based on this. I'll run that. And we get, yes, get some output. And I should clean up. Seems like it's made it. I'll just delete those and double check that it's worked fine. So that's my movie file. Those are the files from last week. I'll rerun the ffmpeg command. and refresh. There's my output WAV file. So you could download that and listen to it. And we can also make an MP3 version to play in Colab. Great thing about these, they're very interactive. They're very responsive to clicks. So here I'll convert the WAV file to an MP3 format. That all happened quite nicely. Oh, look, it brings some metadata from the file through. So we can see that Jenny Green was involved. That's interesting. And the output MP3 file is in there. So now I can use that audio display technique to render an audio player. And I can listen to it.
Okay, pinatraso ni off. Alright?
Ni amur nakangang terus na terus when you
There we go. So did that work for everybody? Cool. Okay, so again, for assessment, we need to see the output of the conversion. Sorry, not that one. We want to see the output of the WAV conversion. The MP3 is not so much for assessment. That's just so that we can preview it easily in the browser. And then interesting thing here to think about is if we look at that archive, I'll go back a page or two. We see that there is a WAV file in here as well. So try downloading that. So can we click view and then we can click download. And just for your own interest's sake, listen to the difference between that WAV file that Nick recorded and the output WAV file that you extracted.
Okay, pinatraso ni off. Alright? Okay.
ban
So I'm not exactly sure of the situation of the setup of the microphones and things. I was trying to look in detail at the video. But in those sort of situations, why do you think that there would be an audio file
Pinatraso ni,
as well as a video file?
okay, pinatraso ni off.
Yeah, it's
Okay, pinatraso ni off. Alright? Okay, pinatraso ni off.
so that's, yeah, I can't hear the difference there either, but we might even use these as an example in one of the coming modules where we use, yeah, true. I can't hear the difference so much locally, but it'll be interesting to use these in a coming module where we look at the features of the audio in a way, so the spectrographic information, so different representations of the audio can show us different things about it in terms of the quality. So what I'm expecting is that the movie file would be a lower quality than the WAV file in terms of the sound, the signal of the speaker's voice, given that the microphone, I'll just open it up again. The microphone that the audio recorder would be attached to, you can see is sitting a lot closer to the speaker, the sound source, than the video camera. So we would expect that the sound coming into the microphone that's attached to the audio recorder is going to be higher quality or clearer. It might even be the same format qualities, but I would expect that it's ever so slightly clearer than the video cameras. It's a higher quality microphone, so it is likely to be picking up more signal than the built-in mic on the camera. So this is a typical setup in language documentation where the mic is, there's a mic attached to an audio recorder, and then there's a video camera that's sort of just capturing general context. It's also really good to, as a language and communication documentation, that the audio signal doesn't capture any of that gestural information that this person is using when she's communicating. You can see there's a lot of sign or gesture in there, and not being familiar with this language, I'm not sure whether that is sign language or if it's gesture, and we'll cover that more in coming modules. What's the difference between sign language and gesture anyway? So the video camera is really important for adding those extra levels of communicative information. And then in terms of the video files, there's also this, the file that we've been working with is an M4V, which is a compressed version of a higher resolution MOV, and you can see the difference in the file sizes there. So I didn't want to put you through the burden of uploading or downloading and uploading a 3 GB file. So we've been working with the 230 megabyte M4V version MP4 compression. So the QuickTime is a higher resolution. It's not lossless, but it's still a lossy compression, as in it's not there's some compression algorithms happening to make the data smaller, and the MP4 is even more extreme compression. So you can see the difference in the file sizes. Same file, same length, but radically different file sizes. So if we were doing any image processing work, we'd likely to be working with the QuickTime version of that. Likewise with the audio, the WAV file is 350 megabytes. I'm sure that the audio file would be quite a lot smaller in file size, so I could try downloading that and just checking. Okay, so that's the audio collab. Any questions about that? Do you want to take a quick break, or should we just continue with the ELAN? All right, so the MP3 is 10 megabytes and my WAV file from the video is 120. So that's a significant difference. The MP3 will be considerably less quality. Maybe we'll just keep going. The ELAN stuff will be quite a lot quicker to get through because we're not downloading such big files. We're working with text. So Leo, this recording, the Prac's being recorded, so I'll share the video with you afterwards. The tutorial that we're going through is here. So we've just done the audio collab. So you'll be able to either follow along just by stepping through that with the assessment criteria. So I'll just drop that in the chat again. Yeah, so when you're ready, you can go back through the audio collab and look at the assessment material, the assessment criteria for that. And we're about to look at the ELAN collab, which will work with some ELAN files and look at the annotations in the tiers. So Leo, you maybe skip the audio one for now so that you can follow along with the ELAN one, and we can catch you up with the audio one afterwards. So we're doing this with again in Colab. Let's begin with at least looking at what an ELAN file is as a reminder. Or just look here. Here's some I prepared earlier. So this is what we call a toy corpus. It's a minimal set of recordings that have been transcribed. So this is a subset of the full corpus. So the corpus being the collection of language recordings. And we made this toy corpus. So the original corpus is much larger. It's 2 gigabytes worth of data. And as we develop language technologies, when we're working on like developing a script or something, often we want to work with a subset of the corpus to make it easier to develop the text. So we've put this toy corpus together just for that reason. Consequence is that it's tiny. So there's only a few minutes worth of data here. So when we use that with, say, a tech like speech recognition, it's not going to give us any kind of quality output because there's not enough data in there for it to really learn about any statistical significance of things. So it's really just to check that the formats that we're working with are correct. So I've opened up this ABUI1 EAF ELAN file. So ELAN is this interface where we have some ways of viewing the text in this annotation. We have this middle section is a media viewer. I can play sections of that. Let's try and get there. And then below that is an annotation. So this is a transcription of what's being said. You can have multiple tiers or multiple rows of annotations, and they can be transcriptions or they could be translations. Let me show a more complete example. So this is from the Gurindji Creole corpus, and you can see, if I get to somewhere where there's some data, ELAN's kind of buggy in a lot of its interface on the Mac. So you can see here that there's this is a reference annotation. So this groups all of these annotations below it, and then we have a transcription tier, and then we have I think this is a token tier. So this breaks the transcriptions into word tokens. Parts of speech tier, so PS, adverb, verb, noun. STEM, maybe a STEM tier, ST, not sure what that is. So these prefixes on the tier names are conventions that the linguists work with, or the language workers. Now this LA is interesting, and this is a language code. So this shows us that within this utterance, which I can play for you. Nope, nothing, no crocodile. This language tier shows us that some of these words are Creole and some of these are Korinji language. So we can look through it. This whole file is all set up in this same sort of way. So this is a annotation convention that has been used in this corpus. So this is a much more sophisticated ELAN file than the ones that we'll be working with. We're going to play with the toy corpus. I'll get ELAN out of the way now. Okay, so like the last collab, we'll connect it, get it running, and then we'll install some things. Now, I might just disconnect my old one. Oh no, maybe it'll turn itself off. Let's reload it, clear it. Okay, so if you do want to forcibly disconnect a collab, up in the menu, the runtime, you can interrupt, restart, or reset the runtime. So I think if you do factory reset, it'll wipe out the files that you've uploaded, and it'll erase or lose the packages that you've installed. So if you do a factory reset, I'm happy to do that now. Factory reset, it'll take everything back to vanilla how it was before. So all of this stuff's gone. If you were to run any of these, like this cell here, which is expects the drive to be mounted, I'll get an error that the drive's not there because we haven't mounted it previously. So no file. Okay, so I'll reset that again and then move on to back to the ELAN one. Okay, let's begin by connecting the runtime. And we'll install some packages. Now, this little package that we use here, PyMPI, I'll just bring this to your attention because it's really handy Python interface for working with these ELAN files. So PyMPI version 1.7. So this gives us a way of working with ELAN files, which are simply XML files. So how about I open one up in, dropped it. I'll open up one of these XML ELAN files in a code editor. And here we can see the format. So it's an XML file. It has all this, these nodes, give it the format. We've got timing information is held here. And then you can see here are the annotations. So if I open that one up in ELAN, I think this one actually might break because I think I did something wrong with the annotations. Where was there we go. It's asking me to locate the audio file. It doesn't actually say that is what it's doing. So this is just from habit. I know that it's asking me about that. Okay, so this is, again, this is what the file looks like here. And looking at the structure of it, the XML formatting, this is how it appears under the hood. So that's pretty basic. When there's only one annotation, there's only a start time and an end time. If we had an hour's worth of recording, then there'd be lots of these. So being XML, there are a lot of different ways you could work with this. You could work with it using Python XML packages. I just happen to like using this PyMPI because it gives us some nice interfaces to working with the annotations, the tiers. So it's reasonably well documented as well. You can click through into the docs and you can see that we could use, say, command like filter annotations, and we can get all of the annotations out of it's an hour-long LAN file based on certain input or start times, end times. We could get all of the annotations from a particular tier. We can do tier manipulation, so it's kind of useful. However, the norm or the easiest way of doing of installing it with pip install, which you might expect doing like that, and it happens to be called PyMPI-Ling on the pip installer. This is a very out-of-date version, so they haven't updated the pip installer package. So here we're installing it from source. So this is a technique for installing Python packages that are published at GitHub. It does mean that we get this pretty nasty errors during the installation process, but it'll get there in the end. So once it installs, then we import that and a package called collections and glob. There's some information about those up there. So I'll run this cell and we'll see it will get the data, get the repository. You can see this nasty looking error message. It tells us that it failed building the wheel, and then it failed building. However, it actually successfully installed. So ignore the error and the fail message here. As long as it's successfully installed, then and using version 1.7, then we're good. Now again, I've uploaded some files to our dev corporate repository. I'll just have a look at this. So github.com/codal/devcorpora, and I've added this folder here, abui elan punctuation, inside which is a transcribed folder, and there's a bunch of files here. So we can see that these are some annotations. These are some files which I've arbitrarily dropped a whole bunch of punctuation into, which makes no sense whatsoever, but we'll strip out using the Colab. So the point of this activity is that we'll process this corpus, we'll convert it into a JSON format, so that might be more easy to use in other language tech, and we'll clean it by removing these punctuation. So this file has multiple tiers. Try and imagine what that would look like in a LAN compared to the simple one that we have here. So again, if we would try to do wget on that address, it would download this whole page, which we don't want. We need to get the raw file, and we can do that by clicking the raw button here. And because this is an XML file or a text file, it displays it. We can see that this is actually what we want, and you can see that the address is different. So it's at this raw.github user content domain, and then that's the rest of the path. So here we do this 4 times with these 4 different files. I'll run that. And I'm just going to download these, not into the Google Drive, but just into the file system here. Because they're small, it doesn't matter if it disconnects, it'll only take a second to download them again. Okay, we can see the progress. They've all downloaded very quickly. Everything's saved. And I can see them there, but hey, why not make a list of just those files so that we can work with them using Python list rather than individually processing the file. So again, with the toy corpus, we've only got a few files, but a typical language documentation corpus, here's one that has been worked on for many years. So there's how many? 1,190 folders containing a file each for the most part. So we want to get these corpus into a format that we can iterate easily. So glob is a Python package which gets information about the file directories, and this command makes a list of all the files that match this pattern. Say .eaf is the elan file format, and then by writing elan files here, we're just printing that out so that we can see the files that have been downloaded. So that looks good so far. Now, it's interesting that in elan, these tiers are kind of arbitrary. You can do some different sorting methods. So I'll see if I can open one of these up and work with it. Dev corpora. Okay, so this is the first file that we're working with in the dev corpus. And there's my pretty nasty insertion of punctuation. Now here we can reorder, I should be able to reorder the tiers by dragging and dropping within the interface. Sometimes. And so across a large corpus, elan, there's no requirement for all the tiers to be consistent. So the next thing that we'll do in the Colab is to look at which tiers occur and the frequency that they occur across all of the files. So this is something that comes up a lot. And in the early versions of Elpis, we forced linguists to use a tier name. So across the whole corpus, we could only extract annotations that were on a consistently named tier. So you can imagine if there were 1,000 files, you'd have to go through and duplicate tiers. So if there was no consistency in the tier naming, you'd have to add that consistency afterwards. That's quite tedious for a lot of big data sets. So we've got some other techniques which we will look at in the speech recognition session. For now, we want to look at the tiers that are in these files and print out some information about them. So this code block, I'll run it and we'll see what we get. So what's happening? We're iterating through these files and we're using this PyMPI package to make an EAF object based on the file. So the elan file, print that, and we can see how we go through. Okay, so for each of these files, notice that it's got some kind of, the order is not significant. So we work with each file, and now this suppressed version warning is handy. So this is the reason that we're using the version 1.7, is because otherwise we can get, sometimes gives us a really nasty error message. Anyway, seems like that's not going to happen with these little files. Okay, so we get the, this is just happening for fun. We can see what the types of tiers. So this is an elan thing. So for this first file, we've got 2 tiers, and the first type is a default type, and the second type is a transcription type. And that's fairly consistent through these 4 files, only that the third file has an extra tier in which some glossing happens. And we can look at the tier names for each of these files too. Okay, so for the file, we've got a tier type, and that's the name of that tier type. So there's some consistency here. So then we stick all of these into a single list. So this is here. So we have a great big list of all of the tiers across the whole corpus. And then we use this collections package to rank them. So by using collections counter, we see that there are 4 tiers named phrase. There are 4 tiers named transcription at speaker 1, and there's a gloss tier and a phrase tier in one of the files. So this just shows us that we can use these Python packages to extract information about the corpus much more simply than it would be to go through and laboriously check each file in Elan, which is what a lot of people do. So for assessment, this is significant. We want to make sure that we're ranking the files in order, and that's all happening quite conveniently with this collections package. Now, a common task in language documentation is, particularly speech recognition work, is to extract the annotations from a consistent tier. This doesn't have to be. Let's just call it a common tier. So I'm specifying the tier name here. And this is the tier that we're going to get the annotation data out of. So what we're aiming to do is to find this phrase tier in all of the files and copy that data out. Yeah. Click madness. So for each of the files, we'll again build this EAF object, and we'll use this get annotations data for tier method, which is part of the PyMPI package, passing in the phrase tier name. So annotations at that point will be probably a list. Okay, so there we can see it's giving us a list with this annotation tuple, start time, end time, and then the value of the annotation. You can see the punctuation madness happening. So for one of these files, we've got 2 items, start time, end time, annotation, and then another. So this file has 2 annotations in it. Now we break these annotations down into start, end, and text values, and then we can format these into an object to create this data structure. So this is now a suitable data structure that we could save as a JSON file and then potentially export to something like a dictionary building app or to use in other processes. So this is very similar to the intermediate data structure that we use in ELPIS, where all of the annotations in a corpus are combined into a massive annotations object with file information, start time, stop time, and transcription time. We also include things like speaker names if they're known. Now the cleaning here happens with a click of a button. We can import this string package, and let's look at what string.punctuation is, and then we'll use the string.punctuation to strip out punctuation from these annotations. So we're going to iterate through this annotations data object, and for each transcript, we'll clean it. And so a nice way of doing that in Python is to use this translate method, where we're translating using these punctuation. Essentially, this is just going to replace anything that is matched in the punctuation string with a blank, or essentially deleting it. So I'll run that and we can compare the transcript. So it's updating the transcript value with the clean utterance. And you can see the output now is super nice and clean. So at the top there, this is the list, or not a list, it's a sequence of punctuation marks that are used to strip it out. Now, that's certainly by no means comprehensive of the world's punctuation. So depending on the data set that you're working with, you might need to modify that. Something that we do in ELPIS is to make that a user input, where we ask people to, or we offer that as the base, and then offer the users to customize that. Because in some cases, in some languages, these punctuation marks are used to signify things like tone in the language. And by taking them out, you might be affecting the meaning of the communication. Okay, so for the assessment, we want to see that these annotations, as they originally are in this JSON data structure. So it's a list with multiple objects. So I'm just highlighting an object. So the list is designated by the square brackets and the object is designated by the curlies. So we've got a list that's holding the data for the 5 annotations coming from 4 files. So you can see there's one file is a buoy 2. We get 2 annotation objects from a buoy 4, and then 1 each from a buoy 1 and a buoy 3. So we want to see that, and we also want to see that we can clean it using this technique. So there are other approaches to cleaning as well, and in the NLP session, I think next week, we'll look at using other packages, one in particular called NLTK, which also includes some punctuation cleaning libraries, as well as things like stripping out. Another technique that we tend to use quite often is to say strip out all the English words from a corpus.